Okay, so let's unpack this. We usually operate under a very specific mental model when we talk about clean cars.
Right.
It's basically a binary switch in our heads. Either it burns dinosaur juice and puffs out smoke, or it runs on batteries and saves the world.
Exactly. The classic good versus evil framing.
Yeah. And if the tailpipe is clear, or better yet, if the tailpipe doesn't even exist, we just pat ourselves on the back, wrap up the discussion, and go home. Job done.
That is the traditional linear view. It is what we in the industry call chemical governance. You measure the chemistry of the exhaust, and if it passes a litmus test, you are compliant.
Right, chemical governance. But I've been reading through this massive stack of documents you sent over regarding the new Euro 7 regulation.
Regulation EU 2020-41257.
That's the one.
Mhm.
And my head is actually spinning because this model, this binary idea of clean versus dirty, it's completely dead.
It is obsolete.
The definition of clean has totally shifted. It's not just about chemistry anymore. It's about physics. It's about code. It's about, well, I mean, it's about dust and noise and invisible electromagnetic waves.
You are hitting on the precise paradigm shift we are facing here. We are moving from the era of tailpipe management to the era of total vehicle hygiene.
Total vehicle hygiene. I like that phrase.
And frankly, if we look at Euro 7, it is not just a standard rule update. It is a massive system shock. It is arguably the most extreme regulatory filter the global automotive industry has ever faced.
A system shock. That feels really heavy. But, before we get into the doom and gloom of it all, let's frame this for the listener. We're doing a deep dive into Euro 7. This is the new law of the land for Europe, but we know the Brussels effect is a very real thing.
Oh, absolutely. The Brussels effect dictates that if you want to sell a car in the world's largest single market, you have to follow their rules.
Right, and it cascades down, doesn't it?
It does. Markets like India, Southeast Asia, and eventually even China tend to align their technical standards with these UNES regulations. So if you are a powertrain engineer sitting at Ford in Detroit or Toyota in Aichi, this is your new reality regardless of your local laws.
So what's our mission today? We have technical reports on emission strategies. We have deep dives into brake dust, battery durability mandates. I mean, it's a mountain of material. How do we tackle this without turning it into some dry textbook legal briefing?
We need to be highly strategic. We are going to adopt the persona of a McKinsey analyst meeting a chief engineer. We need to break this down using a rigorous top-down MECE approach.
MECE, remind me what that stands for again.
Mutually exclusive, collectively exhaustive. We are going to deconstruct the 4 critical pillars of compliance that define this new era. We will make sure there is no overlap between our points, and we will make sure we cover the entire landscape.
Okay, I am on board. What are the 4 pillars?
First, we have emissions, which is transformed into extreme hygiene and digital surveillance. Second, we have EMC, or electromagnetic compatibility, which is the invisible battlefield. Third, we have NVH, meaning noise and vibration. And finally, the life cycle, which covers eco-manufacturing and closed-loop recycling.
4 solid pillars. And what is the timeline for all of this? When does the hammer fall?
The timeline is critical. For light-duty vehicles, we are looking at implementation by late 2026 into 2027.
That is tomorrow in automotive time.
It is essentially today. That means hardware designs are freezing right now. Software validation is happening right now. That is what determines who survives. If a manufacturer cannot master the integration of chemistry, physics, and code by that window, they are effectively filtered out of the market.
Okay, let's dive straight into pillar 1, emissions. And right off the bat, I want to challenge the basic premise here. I originally thought Euro 7 was just Euro 6, but, strictly lower numbers. But you're calling this extreme hygiene and digital surveillance? That implies a change in kind, not just a change in degree.
It is absolutely a change in kind because the fundamental mechanism of governance has changed. Let's look at the tailpipe first, specifically for light-duty vehicles, or LDVs. The headline you read in the news isn't just that the limits are lower. The big news is that they are now fuel neutral.
Meaning diesel and gas are treated exactly the same.
Correct. No more separate, easier targets for diesel. But the real killer, the thing that is keeping engine designers awake at night, is what we call the nano frontier.
The nano frontier, that sounds like a sci-fi movie.
It's pure physics.
Mm-hmm.
Previously, under the old Euro 6 rules, we counted particulate matter basically sit down to 23 nanometers.
Okay.
If a solid particle was 22 nanometers wide, legally speaking, it simply did not exist. It was invisible to the regulator. Euro 7 drops that measurement threshold down to 10 nanometers. This is known as the PN10 standard.
10 nanometers. I mean, I can't even visualize that. That is incredibly small. We are talking about particles that are barely solid matter at that point.
Exactly. At 10 nanometers, particles actually stop behaving like normal dust. They start behaving like a gas. Yes. They follow Brownian motion, they bounce around randomly, they don't just float along and get caught in a traditional filter mesh. They literally drift through the microscopic walls of the filter substrate.
So the old chain link fence-style filters, they just don't work anymore.
Not without significant engineering modifications. You need incredibly dense filter structures. And here is the massive strategic implication for the industry. Previously, gasoline engines, specifically those with port fuel injection, could often get away without using a particulate filter at all.
Because they ran clean enough to pass the old 23 nanometer limit?
Precisely. They got a free pass.
Yeah.
But with the sudden drop to 10 nanometers, that free pass is completely gone. Almost every single internal combustion engine, regardless of whether it is direct injection or port injection, now requires a gasoline particulate filter, or GPF.
Wow.
There's a massive hardware cost, a packaging nightmare, and an exhaust back pressure issue added to every single unit rolling off the line.
So it's basically the end of the cheap, simple gas engine. You have to bolt on this highly complex filtration system no matter what.
Yes. And if you think the light-duty vehicles have it tough, the heavy-duty vehicle sector, the HDVs, they're facing an absolute bloodbath.
The trucks and the buses.
Yes. Implementation for them is 2028 to 2029. And the NOx limits, nitrogen oxide, are being slashed dramatically.
Yeah.
We are going from an allowance of 460 milligrams per kilowatt hour down to a staggering 200.
From 460 to 200. That is a reduction of more than 50%. That's not just a software tuning update. That sounds like you need to invent a whole new engine architecture.
You practically do. To meet that, it forces a move to incredibly complex hardware, like dual SCR systems, that is selective catalytic reduction.
Right, the systems that inject urea, like AdBlue, into the exhaust.
Exactly. But now you need two of them. You need one unit mounted incredibly close to the engine block itself.
Why so close?
To handle cold starts. Catalytic converters do not work when they are cold. They need heat to trigger the chemical reaction.
Ah, I see. The cold start problem.
Under Euro 7, you are fully accountable from the very first second of engine ignition. You cannot wait 5 minutes for the exhaust pipe to warm up while you pollute the neighborhood.
So you have a close-coupled SCR to grab the emissions right out of the gate?
Yes. And then you have another massive SCR system mounted further back under the chassis to handle the high-load, high-temperature highway driving. Plus, on top of all that, Euro 7 is introducing limits for gases that were never forcibly regulated like this before. Ammonia, nitrous oxide, and non-methane organic gases.
Wait. Ammonia, like the cleaning product?
Yes, NH3. Ironically, ammonia slip happens because we inject urea to kill the NOx. If you inject too much, unreacted ammonia comes out the tailpipe. Now that is strictly capped, and nitrous oxide, N2O, is laughing gas. But it is roughly 300 times more potent as a greenhouse gas than CO2.
300 times. That is wild. And the sources also mentioned methane, right? CH4.
Yes. This is specifically targeting natural gas trucks. Methane slippage from those engines is now a huge liability. They are essentially treating the car as a localized driving greenhouse gas source. It is total accountability.
Total accountability.
And it's not just in the laboratory anymore. The RDE, the real driving emissions testing, has vastly expanded its boundary conditions. The lab is now the real world.
What does that mean in practice?
It means you have to prove your car is compliant at altitudes up to 1,800 meters and in ambient temperatures up to 45 degrees Celsius.
So you can't just tune the engine to pass the test on a nice 20-degree day at sea level with a light breeze. You have to pass the test while hauling a heavy load up an alpine pass in the middle of a massive summer heat wave.
Or dragging a trailer on a freezing winter morning in Scandinavia. The defeat devices of the past, the cheating software, they are mathematically impossible under this new regime because the testing conditions are effectively infinite.
Okay, so the tailpipe is getting violently squeezed. But here is where the total vehicle hygiene concept really clicked in my brain. I was reading the section on non-exhaust emissions, NE. The sources are saying that even if I go out and buy a pure electric car, a zero-emission vehicle, I am still technically a polluter under Euro 7.
You absolutely are. Because pollution is not just combustion anymore. It is friction. An
Friction.
electric vehicle, a BEV, has zero tailpipe emissions, yes. But it is very heavy. It has tires, it has brakes. friction inherently creates particulate matter.
Brake dust. I mean, I've wiped it off my rims 1,000 times. I just never really thought of it as a tightly regulated environmental hazard.
It's a massive hazard in urban environments. And Euro 7 is stepping in with UN GTR number 24. They have set a very strict limit of 7 milligrams per kilometer for PM10 from brakes on all light-duty vehicles.
7 milligrams per kilometer. That sounds incredibly tight. But hold on. Brakes work by friction. You literally rub a sacrificial pad against a metal disc to stop 2 tons of metal. It creates dust by definition. How do you legislate physics away?
You have 2 primary engineering levers to pull here. One is technological, and the other is systemic. The technological solution revolves around advanced material science. We are seeing a massive push toward laser metal deposition, or LMD.
Laser metal deposition, what exactly is that?
Manufacturers are taking standard iron brake discs, and they are coating them with tungsten carbide using extremely high-power lasers.
Tungsten carbide, isn't that the stuff they use in industrial mining drill bits? That cannot possibly be cheap to put on a family hatchback.
It is definitely not cheap, but it is extremely hard. It drastically reduces the physical wear rate, meaning significantly less dust. We are talking up to a 90% reduction. It also totally prevents rust, which is actually a massive safety problem for EVs.
Rust. Why is rust a bigger problem for an EV?
Because EVs use their physical friction brakes so rarely, they rely heavily on the electric motor for braking. The physical discs just sit there exposed to rain and salt, and they corrode. The tungsten carbide stops that.
Right, regenerative braking. But if coating these discs is that expensive, who ends up paying for it? The consumer, right.
Eventually, yes. But the prohibitive cost of LMD is what pushes manufacturers aggressively toward the second lever, systemic solutions. To meet that 7 milligram limit without buying expensive tungsten carbide for every single cheap car, you have to completely maximize your regenerative braking algorithms.
Meaning you want the electric motor to do, what, 95% of the stopping work, so the physical pads almost never touch the disc?
Precisely. You have to design the software so the physical friction brake only engages in the last few feet of a stop, or during an emergency panic stop.
So the cleanest brake is the one you literally never use. The friction brake basically shifts from being a primary driving system to a specialized fail-safe system.
Exactly. And that leads us to the other friction problem. Tires. We are now looking at UNES Regulation 117.
Right, tire abrasion.
We are now scientifically monitoring the physical weight loss of a tire per kilometer driven.
But EVs are much heavier because of the battery packs, and they have that instant, massive torque. Don't they just naturally chew through tires way faster than a gas car?
They do. It is simple physics again. Mass times acceleration equals force. High torque combined with a heavy battery pack equals very high shear force on the rubber, leading to high abrasion. We are currently seeing tire wear rates 20% to 30% higher on standard EVs.
So tire manufacturers are stuck in a nightmare scenario. They need soft rubber for grip and safety. They need low rolling resistance so the EV has a decent driving range. And now they need low abrasion so they don't fail Euro 7. That sounds like an impossible magic triangle.
That is exactly what the industry calls it, the magic triangle of tire engineering. To solve it, they are moving away from traditional carbon black and natural rubber. They have to develop advanced biocomposite, low abrasion rubber compounds.
Biocomposite?
Yes, using new synthetic polymers and resins that hold their molecular bonds much stronger under intense shear stress while still providing safety grip.
It's amazing. We are literally regulating the microscopic dust coming off the rubber now. Okay, moving to the third part of this emissions pillar. In your notes, you called this the digital snitch. This refers to OBM onboard monitoring.
This is perhaps the most profound philosophical shift for the consumer. We are officially moving from the era of type approval to the era of digital identity.
Type approval meaning the old way, where an automaker sends one golden prototype to a lab, it passes a test once, and then they can build 1 million cars based on that.
Correct. That is over. Now, we have lifetime digital monitoring. The car is effectively testing itself.
Constantly, like every time I drive.
204/7. The car is mandated to be equipped with an array of complex sensors, NOx sensors, particulate matter sensors, ammonia sensors, and it combines these with advanced model fusion algorithms to calculate emissions in real time. If your emissions exceed the legal limits during your casual drive to the grocery store, the system immediately flags it.
And what happens then? Does the siren go off? Does the car just shut down in the middle of the road?
It triggers dashboard alerts to the driver. It permanently logs the violation. And critically, this data becomes an immutable part of the car's permanent digital record. It enters what the regulators call the trust boundary.
The trust boundary. That sounds incredibly Orwellian. I can see the privacy advocates screaming about this already.
It is considered an absolute necessity for strict enforcement. And to prevent people from tampering with it, for example, a tuner trying to erase the logs or a mechanic trying to mask a failing catalytic converter, the regulation strictly requires data hashing.
Unpack that for me. What does data hashing mean in a car?
Within 10 seconds of you turning off the engine, the car's central computer must take all of that trip's emissions data, encrypt it, and hash it.
Cache it.
It basically locks it digitally with a unique cryptographic signature. Once hashed, that data cannot be altered retroactively by anyone, not even the dealer. It is a profound anti-tuning measure.
So if I'm a car enthusiast and I buy a car and I want to tweak my engine mapping to get 50 more horsepower, the car is going to know immediately and it's going to digitally lock me out.
It will log the discrepancy between the expected emissions map and the actual sensor data, hash that violation, and it will likely invalidate your compliance status. You might fail your annual inspection instantly. The car is monitoring its own health to satisfy a government server, not the driver's desire for speed.
Wow. Okay, that is a huge shift. And speaking of health, the final part of the emissions pillar is battery durability. This is specifically for the battery electric vehicles and hybrids.
Yes, under UN GTR number 22, there was a very legitimate fear among regulators that early cheap EVs would flood the European market with low-quality batteries.
Batteries that degrade after 3 or 4 years and leave the owner stranded.
Exactly, which would create a massive toxic electronic waste problem and destroy consumer trust in the electric transition. So they set a hard floor for degradation.
What are the actual numbers? How long does a battery legally have to last now?
For a pure EV, up to 5 years or 100,000 kilometers, the battery pack must mathematically retain at least 80% of its original certified capacity.
80% after 5 years.
Yes, and it goes further. For 8 years, or 160,000 kilometers, it must retain at least 72% of its capacity.
72% after 8 years. That is actually pretty demanding. I mean, my smartphone battery doesn't last 2 years before it starts shutting down at 15%.
Yeah.
How do auto manufacturers guarantee an 8-year lifespan when they cannot control how I charge the car? What if I fast charge it every single day in the scorching heat?
That is the multi-billion-dollar engineering challenge. To legally guarantee those numbers, they have to deliberately over-engineer the battery pack. They need vastly superior liquid thermal management systems to keep the individual cells in the perfect Goldilocks zone of temperature, regardless of what the driver does.
Heating it in the winter, cooling it in the summer.
Exactly. And crucially, they will likely use software to lock away the very top and bottom of the battery's true physical capacity.
Oh, so they give you a buffer.
Yes. As the chemical cells naturally degrade over the years, the software slowly releases that hidden reserve buffer to you, keeping your visible range constant so they don't fail the 72% legal limit. This regulation effectively kills the cheap, disposable EV business model overnight.
So that is Pillar 1, emissions. It's drastically cleaner, it's cryptographically watching your every move, and the battery is legally mandated to last. I am exhausted just thinking about the engineering hours required for that. But let's keep moving. Let's move to Pillar 2. In the outline, you call this the invisible pollution, EMC, electromagnetic compatibility.
Correct. The electromagnetic battlefield.
Now, to the average person on the street, this is basically dark magic, but you're telling me this is actually the #1 failure risk for modern vehicle architectures. Why now? Cars have had alternators and FM radios for decades without causing a crisis.
Because a modern EV is no longer just a car with a radio. It is essentially a rolling 800-volt supercomputer.
Right.
You have massive electrical currents moving from the battery pack to the drive motors. And physically routed, right next to those high-voltage cables, you have incredibly sensitive, low-voltage sensors for autonomous driving, radar modules, Ethernet cables, and high-speed 5G antennas.
So the magnetic field from the big motor cables could literally scramble the data going to the self-driving autopilot.
If you do not manage EMC properly, yes, that is the nightmare scenario. A sudden surge in the motor could cause the braking sensor data to drop out for a millisecond. The culprit driving this massive new waves of interference is actually the new technology we're using to make EVs more efficient. Wide bandgap semiconductors.
Wide bandgap, like silicon carbide, right? We hear about that a lot as the magic chip that makes fast charging possible.
Exactly. Silicon carbide and gallium nitride, or GaN. They were revolutionary. They allow for much higher switching frequencies inside the power inverters, which drastically cuts energy loss and improves range.
So what's the catch?
There's always a trade-off in physics. The catch is that they create what we call extremely high dVdt.
dVdt. Let me dig back into my high school calculus. Change in voltage over change in time.
Precisely. These new semiconductor switches turn on and off incredibly fast. We're talking voltage changes greater than 100 volts per nanosecond.
Per nanosecond. That is violently fast.
That extreme speed creates massive, sharp voltage spikes. And those spikes create what engineers call ringing. It creates intense electromagnetic interference in the high kilohertz and megahertz ranges.
Ringing. Like hitting a tuning fork.
Like hitting a massive bell very, very hard. The entire high-voltage electrical system of the car starts to resonate with chaotic electromagnetic noise. It radiates outward like an antenna.
And that invisible radiated noise is what blasts the sensitive computers on board.
Yes. We use specialized near-field electric probes just to find this noise. It is constantly leaking from the DC converters, from the motor control units. It's like high-pressure water leaking from a pipe, except the water is pure electromagnetic radiation.
So how on earth do we stop the leak? We can't just wrap the entire car in a giant tinfoil hat, right? That adds too much weight.
We need deep, system-level defense. And this is where the hardware evolution gets really interesting. We are seeing a major shift toward using nanocrystalline cores in the electrical filters.
Nanocrystalline cores. That sounds extremely high-tech. Why are they better than whatever old stuff we used to use?
It comes down to magnetic permeability and saturation limits. Traditionally, to block interference, we used ferrite cores, basically heavy iron oxide ceramic magnets. You wrap the wire around them, and they soak up the noise.
Right, like those little heavy cylinders you see on old laptop charger cables.
Exactly. But ferrite saturates very easily. Once it is quote-unquote full of magnetic flux, it simply stops filtering the high-frequency noise. Nanocrystalline cores, on the other hand, have 3 times the impedance, the natural resistance to this noise, and they do not saturate nearly as easily.
So they can handle the violent voltage spikes from the silicon carbide chips.
Yes. Plus, because they are so efficient, you can shrink the physical size of the filter by 50%.
Oh, so you get vastly better filtering in half the space and weight. That is a massive win-win for packaging.
It is. Another fascinating hardware technique is called flux cancellation. This is pure, intelligent PCB layout design.
Printed circuit board layout. How does that cancel noise?
You route the forward-flowing high-voltage current trace and the return-flowing current trace on the board so that they are placed completely parallel and as close to each other as physically possible.
Oh, I see. Because the currents are flowing in opposite directions, their magnetic fields spin in opposite directions?
Exactly. The fields are out of phase, so they naturally cancel each other out.
It's literally like active noise-canceling headphones, but using raw physics on the copper traces of a circuit board.
A perfect analogy.
Yeah.
But you know, the absolute biggest change in the EMC pillar isn't actually the hardware itself. It's the development process. We call it shift left.
Shift left, moving the timeline of testing.
Yes. In the old days, you engineered the components, built a physical prototype car, drove it into a heavily shielded anechoic chamber, blasted it with antennas, found a critical interference problem, and then scrambled to slap some heavy shielding tape over a cable to fix it.
A Band-Aid fix at the end of the line.
Exactly. That method is completely dead. It is too slow and way too expensive now. By the time you have a physical EV prototype built, the tooling is done. It is too late to move a high-voltage cable that's frying the Ethernet network.
So you have to test the car before the car even exists.
You use XDT, executable digital twins. You meticulously simulate the electromagnetic interference of the entire vehicle architecture 6 to 9 months before a single physical screw is turned.
You simulate the invisible magnetic waves of a car that hasn't been built yet.
Yes. You run the car in a high-fidelity virtual environment. You mathematically simulate the fast switching of the silicon carbide chips, the exact geometry, the cable routing, the grounding points, all to see if turning on the windshield wipers will crash the dashboard infotainment system.
That is just wild. The car is effectively validated in the matrix before it ever hits an assembly line.
It has to be. The complexity leaves no other option. The new testing regulation, UNR 10.07, mandates that we test frequencies all the way up to 6 gigahertz. We are now forcibly covering the Wi-Fi and 5G cellular spectrums to ensure the car doesn't interfere with mobile networks.
Wow. All right, so that is the invisible noise covered. Now let's move to Pillar 3 and talk about the audible noise. NVH, noise, vibration, and harshness. I've definitely noticed this when riding in EVs. They are very quiet, obviously, but they aren't totally silent. In fact, sometimes the random noises they do make are infinitely more annoying because there is no big engine block to drown them out.
You were describing the loss of the masking effect. The internal combustion engine was a wonderfully loud, broadband noise generator. It was a great acoustic blanket. It covered up a multitude of engineering sins, wind whistling over the mirrors, creaking suspension bushings, the low hum of the tires on the asphalt.
Right.
When you remove the roar of the controlled explosions under the hood, the passengers suddenly hear absolutely everything else.
So what are the specific noises we are trying to kill in an EV?
The single biggest offender is the tire, specifically a phenomenon known as tire cavity resonance.
The air vibrating inside the tire itself.
Yes. The physical volume of compressed air inside the tire naturally vibrates as the tire rolls over the textured road. It creates a very distinct structural hum right around the 180 to 240 hertz frequency range.
180 to 240 hertz, that is a very low booming drone.
It is extremely fatiguing for passengers on a long highway trip. It causes literal headaches.
So how do the engineers kill a drone that is happening inside a spinning rubber donut?
We use FIT technology.
Foam and tire.
Foam and tire.
Literally.
Literally.
Yeah.
The tire manufacturers are bonding a thick strip of specialized polyurethane acoustic sponge liner all the way around the inside cavity of the tire.
It just absorbs the bouncing sound waves?
Yes, it breaks up the standing air waves and effectively kills that specific 200 hertz structural resonance before it travels up the suspension into the cabin.
It's acoustic treatment for your wheels. That is brilliantly simple, but highly effective.
Precisely. And for the cabin itself, we are moving entirely away from the old-school, heavy, asphalt-based, sound-deadening mats. We are using advanced passive material science, lightweight shielding, layered acoustic barriers, brittle rubber composites, things that block a wide frequency of sound without adding any significant mass.
Because in an EV, adding extra weight is the ultimate enemy of driving range.
Exactly. But passive foam only goes so far. What about the electric motor itself? You mentioned earlier you hate the high-pitched sounds.
Oh, the dental drill sound. That high-pitched, incredibly piercing whine when you accelerate hard, that drives me absolutely crazy.
That is the e-motor whine. It's an electromagnetic acoustic issue. It originates from the microscopic deformation of the metal stator caused by the intense magnetic forces switching inside the motor. To fix that, foam won't work. We have to use active acoustic control.
Active control, like active noise-canceling headphones again.
Yes, but applied in two distinct ways. First, there is standard ANC inside the cabin. We place beam-forming microphones in the headliner to detect the exact frequency of the whine, and the car's stereo speakers instantly play an anti-phase acoustic wave to physically cancel it out in the air near your ears.
Okay, that's the brute force way.
Yep.
What's the elegant way?
The elegant solution is called harmonic injection.
Harmonic injection. I need you to explain that.
This happens purely inside the motor controller software. You calculate the exact magnetic frequency that is causing the physical metal to whine. Then, you deliberately inject a highly specific, tiny electrical current ripple back into the motor coils.
A countercurrent.
Exactly. This injected ripple creates a secondary magnetic vibration that is exactly physically opposite to the original vibration causing the whine.
So you are using the giant traction motor itself as a giant speaker to cancel its own internal noise at the source.
You are creating destructive interference inside the magnetic field itself. It creates what acoustic engineers call a spectral hole, right where the annoying noise used to be. It completely turns a piercing whine into pure silence.
That is incredibly clever. You're fighting physics with physics, just dynamically tweaking the magnetic field with code.
It is the ultimate software-defined solution to a hardware problem.
Okay, so if we've done our jobs right, we now have a car that doesn't pollute the air, doesn't emit frying electronic noise, and doesn't whine at you. That brings us to the fourth and final pillar of our MECE structure. Pillar 4, manufacture and recycle, the circular economy.
This is what we call the womb-to-tomb tracking system. In the old days, regulatory compliance essentially ended the moment the shiny new car was sold to the customer. Now, under these new directives, compliance strictly extends backwards into how the car is built, and crucially, forwards into how it eventually dies.
Oh, it dies. That sounds very dramatic.
It is a geopolitical and strategic necessity. Let's look at the front end first. Eco-design and material purity. The new regulations strictly mandate design for disassembly.
Meaning when you engineer the car, you can't just permanently glue everything together anymore.
Exactly right. No more industrial adhesives or irreversible welds where a simple mechanical clip or bolt would suffice. If an automaker glues a structural battery pack solidly into the chassis so heavily that it cannot be removed without physically destroying the expensive battery cells, they are non-compliant.
The car fundamentally must be built like Lego so it can be cleanly taken apart later.
Yes, so the pure materials can be recovered efficiently,
Yeah.
and they're legally forcing recycled content into brand new cars now, right?
Wait, I did read this. There are hard legal mandates for new cars to contain specific minimum percentages of recycled plastic.
Yes. The goal is to hit 25% recycled plastic content in new vehicles within a decade. And here's the kicker. At least 20% of that recycled plastic must come specifically from closed-loop ELVs end-of-life vehicles.
Closed loop. So the dashboard of my brand new luxury car literally has to be made out of the melted down bumper of a scrapped 15-year-old car.
That is the mandated reality. You cannot just use recycled water bottles, you must recycle car parts into new car parts. And to strictly track all this complex material flow, we are introducing the Digital Product Passport, the BPP.
A passport for car parts.
Every single battery module, every key electrical component gets an immutable digital ID. It intricately tracks where the raw minerals were originally mined, the exact carbon footprint generated during its manufacturing, and the real-time health data of the unit over its lifespan.
This connects perfectly to that massive data ecosystem you highlighted in our prep notes, Catena X, right?
Catena X. It is a highly ambitious, standardized data ecosystem, primarily driven initially by the German automotive industry, but it is rapidly going global. It uses standard software architectures like Sphera to allow thousands of Tier 1, Tier 2, and Tier 3 suppliers to securely share product carbon footprint data.
PCF data. But wait, suppliers are notoriously paranoid. How do they share carbon data without leaking their secret manufacturing processes to their competitors?
That is the genius of Catena X. The data exchange is cryptographically structured. So a simple bolt manufacturer in Taiwan can say to BMW, this batch of bolts has exactly 2.4 grams of CO2 embedded in it, without ever revealing the proprietary machining speeds or energy sources they use to make the bolt.
Wow, so it creates a totally verified chain of custody for carbon emissions all the way down to the individual screws.
Exactly. It makes Scope 3 emissions tracking actually auditable for ESG reporting. And this entire front-end data tracking leads directly to the back end. High-value, closed-loop recycling. We desperately need to talk about urban mining.
Urban mining, I absolutely love that term. The idea that the city itself, the scrapyard, is the new gold mine.
The car literally is the mine. The global industry is finally waking up to the reality that lithium, cobalt, and nickel are far too strategically valuable and too politically volatile to just crush up and throw in a landfill.
Right. Recovering these metals is a strategic necessity for national security. Europe and the U.S. want to drastically reduce their dependence on foreign mining supply chains.
Exactly. If you can effectively recover 95% of the pure lithium from an old, dead EV battery pack, you mathematically don't need to dig a brand new lithium mine.
And the recycling tech to do this, it's not just some guy smashing the battery with a hammer and melting it down, right?
No, the new facilities are incredibly high-tech. The primary method scaling up now is wet metallurgy, specifically hydrometallurgy. You shred the battery into black mass, and then you use very complex, targeted chemical acid solutions to dissolve and extract the individual raw metals at incredibly high purity levels, purity high enough to go straight back into a new battery.
And I saw notes about using AI in the scrapyards.
Yes, automated AI sorting facilities. High-speed cameras and machine learning algorithms can instantly identify and physically separate different aluminum alloys from a crushed car at the speed of light. It dramatically increases the purity of the scrap.
So the business case for all this heavy recycling isn't just a feel-good, save-the-planet initiative. It's strictly about saving money and securing resources.
It creates highly valuable carbon credits. By using deeply recycled materials, a manufacturer massively reduces their Scope 3 upstream emissions. In a global economy with rising carbon taxes and border adjustment mechanisms, that carbon waste is literal money. It directly offsets the soaring cost of manufacturing.
Okay, so we have systematically marched through the 4 pillars. Emissions and the 10-nanometer limit, EMC and the silicon carbide noise, NVH and the harmonic injection, and the life cycle with Catena X and urban mining. When you step way back from all this technical detail, when you look at this Euro 7 paradigm shift from 30,000 feet, what is the ultimate synthesis here?
The ultimate synthesis is that Euro 7 is not merely a bureaucratic regulatory hurdle, it is a brutal existential filter.
A filter for whom? The engineers.
A filter for the car companies themselves. It will violently filter out the automotive companies that cannot master deep integration. In the past decades, you could be a truly great mechanical engineering company, build a solid engine, and survive. Or recently, you could be a great software startup, buy some batteries, and survive.
But not anymore.
Euro 7 rigidly demands that an automaker is world-class at chemistry, advanced physics, and complex code simultaneously.
Deep integration is the killer app.
It is the only way to survive. The legacy companies that still treat these disciplines as siloed departments, where the exhaust emissions guys are down the hall and never talk to the motor software guys, they will catastrophically fail. The systems are now too interconnected.
Because the brake dust compliance literally depends on the electric motor software's regeneration algorithm.
Yes, and the electromagnetic compliance depends on the semiconductor purchasing choice. It is all one incredibly sensitive, breathing organism.
And for the listener, the everyday person who just wants to buy a car in 2027,
For the listener, you need to realize that the next vehicle you purchase is fundamentally, philosophically different from anything you've owned before. It's not just a transport machine. It is a digitally monitored, actively shielded, cryptographically locked, fully recyclable asset.
it is cleaner, obviously.
Much cleaner,
Yeah.
but it is profoundly more complex.
It's a node in a network.
It is a node, and it is constantly watching itself.
Which perfectly leads me to my final thought. The ultimate provocation that keeps bugging me after reading all these source documents.
Yeah.
You mentioned the OBM, the digital snitch.
Yes.
The car is mandated to constantly monitor its own emissions. It cryptographically hashes its own compliance data. It effectively reports its health to the state authorities.
It does.
So here is the provocation for everyone listening. If your car is strictly monitoring its own health 24/7 to satisfy a government server, if the car can unilaterally invalidate its own legal compliance because you missed a mandatory software update or you tried to tune the engine, who actually owns the car?
That is the $64 million philosophical question. You physically hold the title. You pay the monthly bank loan. But the regulatory algorithm effectively controls the ultimate functionality of the asset.
You are just the physical operator, but the state or the algorithm is the ultimate admin.
In many critical ways, yes. We are rapidly moving toward a societal model of compliance as a service. The vehicle physically serves the regulation first, and it serves the driver second.
Wow. Compliance as a service. That is a heavy, fascinating thought to mull over the next time you get into your driver's seat. The car is cleaner than ever, it is quieter than ever, but it's definitely not just your isolated machine anymore.
It is a networked partner and an unforgiving snitch.
A partner and a snitch. I absolutely love that. Thank you so much for guiding us through this incredibly complex labyrinth of Euro 7 today.
My absolute pleasure. Despite the hurdles, it really is a fascinating time to be an automotive engineer.
It truly is. And a huge thank you to you, the listener, for surviving this deep dive with us. The next time you walk out to your car and look at your tires or glance at those brake discs behind the wheels, I hope you give them a little nod of respect. There is a staggering amount of physics, chemistry, and code fighting a silent war down there. Keep exploring, and we'll catch you on the next deep dive.